Good morning, dear students. Today we're having the third practical lesson over the advanced calculus, and on the previous lesson we were integrating rational fractions and some irrational functions, and today uh, our topic is integration of trigonometric expressions and trigonometric substitutions for irrational functions. So let's start calculating integrals. So the first one, so let's integrate a. Actually, so what do we have here in this integral? Here is the product of trigonometric functions, so cosine of x multiplied by sine of 3x. And we have to uh, transform this product into the sum, because we don't have such properties of integral. So integral from the product, so analogically for derivative, so we must transform it to the sum. And uh, actually, yeah, let me remind you some uh, trigonometric formulas. Yeah, to be honest, uh, I don't remember all formulas, yeah, because it's not so easy to remember all of them. So let we look these formulas. Mm, I guess not these formulas. Maybe this. Yeah, so product of trigonometric functions, products are the following. So what is interesting for us? So sine alpha plus cosine alpha. So we have the following expression. So let's move 1 second out of integral. So we have the following expression. So first of all, sine of alpha plus beta. So alpha plus beta equals 4x. So sine of 4x and plus sine of alpha minus beta. So argument of beta is argument of cosine. So plus sine of 2x. So be attentive, be careful when uh, converting into the when converting sum to the product. So now we can integrate this sum by using differential entry technique. So we will have the following integral. So 1 second of minus 1 over 4 cosine of 4x plus 1 over 2 uh, sine or cosine. Stop. Yeah, so minus 1 second over cosine over 2x plus c. And that's all. Yeah, we also can expand brackets. We can move or move minus out of brackets. So different transforms. Do you have any questions about this exercise?
No questions.
Yeah, and so stop. Cosine multiplied by sine, by the way. So here is a mistake. Okay, need to correct it. Well, part B is analogical to A, but we have three. So product of three trigonometric functions. So let's skip it for now. And let's solve exercise C. So sine square of x. Your ideas, suggestions how to calculate this integral. So how to transform it. So you don't have an idea. Okay, so now we need to reduce the degree of the sine by using these formulas. And for cosine square of x, 1 plus cosine of 2x. I will not erase these formulas for now, so they can be useful for us during the lesson. So, what are we doing here? So we just reduce the degree with this formula. So I will even copy and paste it. And now we have a simple integral. Yeah, let me move to another line. So the following integral: x minus 1 second sine 2x plus c. So any questions about this exercise?
No question.
Okay, no questions. Let's move to the next part. So for squares, we can just downgrade so we can just reduce the degree. So moving to part D. So we have the following integral cosine cube of x, and your suggestions how to solve it. Yeah, we know. So there are trigonometric formulas for expanding cube. So for reducing cube, if I'm not mistaken, but that's not the best approach for such integrals. Okay, so let's transform this expression. So let's write it in details. So we have cosine square of x multiplied by cosine of x. And now we do the following stuff. So how cosine of x can be cosine square of x can be rewritten? So using the main trigonometric equality. So this expression. So 1 minus sine square of x. So your idea what to do next? Your suggestions? So approach that you already know. Do you see a differential? You can raise your hand. Okay, so let me remind you. Which differential do we have here? So this expression remains without changes, and cosine of x dx is actually differential of sine x. So now we integrate this expression with so by sine of x variable. Yeah, so we already can write even antiderivative. So the integral is the following: sine of x minus 1, minus 1 over 3 sine cube of x plus c. So any questions about this exercise? How to solve? Okay, I see that no questions, that everything is understandable. So let's move to exercise E. We have the following integral. So actually, when we have such so function with odd exponent, so with odd degree over trigonometric function, so we can use the differential entry technique. Okay, so moving to the next. So sine square of x multiplied by cosine of fourth degree dx. Okay, let me look into how, yeah, so how I used it, oh, so how I solved it. So actually for this integral, we have to transform it into, so we need to transform into the sum. So yeah, so transforming in, so we will use actually approach of so degree reducing. So again, so let's do it. So let's move 1 second out of integral. So 1 minus cosine over 2x. And for, okay, let's leave it without changes for now. Cosine cube of x dx. And then we will also, we can do the following. So 1 minus sine over, so minus sine square of x in power of 2. So this is how we rewrote cosine of x in power of 4. Okay. So now let's reduce this expression. Well, or maybe it's better to to perform some actions below, so just not to lose everything. So let's reduce this expression. So 1 minus sine square of x in power of 2, so equals the following. So 1 minus 1 second 1 plus 1 minus cosine over 2x in power of 2. So now expanding brackets. So 1 minus 1 second, so 1 second plus cosine of 2x. And now calculate, so this square. So 1/4 plus cosine of 2x plus cosine square of 2x. And it will be already in power of 1. I can even remove brackets. We don't need them. And now let's calculate, let's also reduce the power of cosine square of 2x. So plus so plus 1 second and plus 1 second cosine over 4x. And finally, let's add three coefficients. So 3/4 and 1 second goes away here. So we have the following expression for now. So 1 over. So let's write the integral and see what do we have on the next line. So now it looks like this. Let me also move 1/4 out of brackets. And then we will expand everything. So again, we will have to use some combinations. So we will have to reduce the degree. We will have to also transform product into the sum. So yeah, a lot of different stuff to do. So multiplying firstly this expression by 1, and we have this, and minus, so multiplying by cosine of 2x minus 3 cosine of 2x minus 4 cosine square over 2x and plus or minus yeah, here plus in the brackets plus uh, 2 cosine of 2x and cosine over 4x. And these expressions will be eliminated. Yeah, so erasing them. Okay. Yeah, by the way, let's also expand these brackets, because we have a lot of similar addends. So 4 cosine of 2x minus 3 cosine of 2x, so cosine of 2x, and it goes away, minus 4 cosine square of 2x minus this expression, so remains without changes. Okay, now let's simplify more these expressions. So cosine, so 4 cosine square of 2x equals 2 plus 2 cosine of 4x. So let's simplify it right now. So because, so if I substitute it here, so it will be reduced a little bit. So -2 minus, stop. Here, -2 minus 2 cosine of 4x. And it will go away. So let's cancel this expression. We don't need it anymore. And also, oh, no, let's remain without changes, but reduce here. And here will be 1. And now let's also transform this product into the sum. So it will be equal cosine of, so it will be sum of cosines. So cosine of 6x plus cosine of 2x. Yeah, so and we have 2 here. Minus and minus here. And as we see that cosine of 2x is eliminated as well. So we had so initial integral was so complicated. So sine of cube of x multiplied by cosine of x in power of 4, and what we have finally. So absolutely, so this function is linear relative to trigonometric functions. So now we can integrate 1 over 8 multiplied by x minus 1 over 6 sine over 6x plus c. So any questions about this exercise? Is everything clear for you? Or you need more explanation? Okay, if no questions, let's move to the next exercise. So, which approach to use when both sine and cosine have so actually when all trigonometric functions have even degree, so you just need to reduce it. So as much as you need. So to transform it to the table integral. Okay, let me erase everything, almost everything. And moving to part F. Okay, so exercise F, what do we have? So cosine, so we have such fraction, cosine of x in power of 5 divided by sine of x in power of 3 dx. Okay, and now let's do some, yeah, let's tweak it a little bit. So what can we do here? So we can, so we will use the differential entry technique, but first of all, we will a little bit we will change. So we will transform this expression. So what are we going to do? first of all. So let's multiply this expression by sine of x and divide it also by x. So now what we will do, we will use the differential entry technique. Okay, let's continue. So now we can move this sine of x under the differential, and so sine of x dx is the differential of minus cosine of x. Okay, so doing the following stuff. So here we have cosine, so cosine of x in power of 5 multiplied by d cosine of x and here, so expression in the denominator will be modified. So we will have such. So actually, what do we have here? Let's expand. So let's reduce this expression. So it will be 1 minus cosine of x in power of 2. And this expression also will be in power of 2. So what do we have here? It is the rational fraction that can be integrated. Well, it doesn't look such simple. Maybe here it is a better variant. Yeah, so yeah, let's. So here is a simpler way to solve it. So let's do the following. So sine of cosine cube, so cosine of x in power of 4 multiplied by cosine of x. And cosine of x dx is the differential of sine of x. So we don't touch denominator, so it remains like this. And we transform cosine of x in power of 4 into this expression. And differential of sine of x. And now let's expand the brackets. What's going on? Yeah. So something is incorrect with using math type. So now expanding these brackets, so 1 minus sine of x in power of 2 will be equal 1 minus 2 sine square of x plus sine of x in power of 4. And now dividing this expression dividing by the denominator, what we will receive. So the following integral. So now 1 over sine cube x minus 2 over sine of x plus sine of x, and by d sine of x. And now we can integrate it, so it's like a table integral. So 1 by sine of x in power of -3. So we will receive so minus 1 over 2 sine of x square minus 2 logarithms over sine x and plus 1 over 2 sine of x in power of 2 plus c. So it is much simpler than even degree. So it's easier to differentiate with odd degrees. So any questions about this exercise?
No questions.
Okay, if no questions, let's move to the next. So G, okay, is the following. So the following integral sine of x in power of 3 multiplied by cosine of x. And again, so let's see what can we do here. So if I multiply, for example, by so I can multiply by cosine of x or by sine. So how better to solve it? So to simplify this solution. So yeah, we will also use the analogical approach to f, but let me remember what. So how to. So if it's the simple solution, yeah. So what do we have? So we multiply by cosine and divide by cosine of x. And cosine of x dx is the differential of sine of x. So and this expression will be also modified 1 minus sine cube or square of x. Well, it doesn't look such so not such beautiful expression. Mhm. I even so didn't continue uh, calculating it. So let's finish calculating. So now let's do the following substitution just for our convenience. So t equals sine of x, and now integrating the rational fraction. So dt and so t cube multiplied by 1 minus t, 1 minus t and 1 plus t. So remembering method of undetermined coefficients. So all this plus yeah, such a big expression, but what to do? So 1 plus t. And now let's move to the common denominator. So 4a. a will be multiplied by t in power of 2 and by 1 minus t square. Then b will be multiplied by t and 1 minus t square plus square, not cube, plus c multiplied by 1 minus t square. Okay, let's move it to the next line. Plus dt cube multiplied by 1 plus t and plus e t cube multiplied by 1 minus t. If I'm not mistaken, a lot of coefficients here will be 0, so it must be quite easy. So for t square minus at in power 4 plus bt minus bt cube plus c minus ct square plus dt cube plus dt in power of 4 plus et cube minus et in power of 4, so nothing lost. And now let's regroup. So for t in power of 4 minus a plus d minus e. Then what about power of 3? Well, so equation with 5 variables. I don't think that we will solve it finally. So let's just receive the system and then we will move next. Plus minus b plus d plus e. So a minus c. Okay. Then plus so what is in front of t? B, only b. Okay. So yeah, b in power of 1, t in power 1. Okay, and the last only c plus c. Okay. So what do we have? So received the following system and some of these variables will be easily eliminated. So this equals 0. This expression equals 0. A minus c equals 0. B equals 0. And c equals 1. So let's even solve it. So a also equals 1 because a minus c equals 0. So a equals 1. Okay, so let's, yeah, no, so 0 here. Okay, so b equals 0, so let's remove it. So d plus e equals 0, and here minus 1. So if I add, and so minus 1 plus So -1 plus 2d equals 0. So d equals 1/2. So we found the coefficients, and e equals -1/2. So the final integral will be the following. So I equals so dt. Okay, let's do this. So 1/t. So b0 plus 1/t cube plus 1 second over 1 minus t. And let me copy and paste it. Oh, no. Okay, so now let's integrate it. So it's almost done. So logarithm of t minus 2 over 2 over t cube plus 1/2 logarithms of module. Yeah, and here minus actually, because minus before t, 1 minus 2 minus 1/2 logarithm of 1 plus t. And plus c, so let's add a wave here, just not to mesh everything up. And the final answer reminding you that you have write like this. So what does t mean? So where t equals sine of x. So any questions about this exercise? So yeah,
No questions.
a lot of actions. So reminded you some previous material. Okay, so what can we solve else before having a break? Okay, let's solve exercise H, and then we will continue after the break. So exercise H, the following. So such interesting case. So tangents in power of 4 of x dx. So this integrals looks quite complicated, but it's not such complicated. So we're doing the following substitution. Oh, here is it. So tangents of x equals t. Then t equals arctangents of x. And stop. X equals arctangents t. And dx equals dt divided by 1 plus t square. So now let's rewrite this integral, and we will see that what we will receive here. So t square, or t in power of 4 divided by 1 plus t over, or divided by 1 plus t in power of 2, dt. So nothing lost here, as I see. Yeah, so everything is okay. So now we can, okay, let me look in what we receive after extracting the whole part. So we receive the following expression. So we have t square minus 1 plus 1 over 1 plus t square dt. So we have a kind of table integral, sum of table integrals, and let's calculate. So 1 over 3 t cube minus t and plus arctangents, no, not cotangents, t. Plus c, and don't forget about old variables. So that's the answer. Any questions about this exercise? Okay, currently I'm thinking about so either go for a break now or wait. Okay, let's go for a break now, and then we'll continue. So 5 minutes for a break. Okay, let's continue. So, now we will so the integral with using universal trigonometric uh, substitution. So you have the following formula here. So we do the following substitution. So we so t equals tangents of x by x over 2. And here how sine and cosine are modified. So how they are transformed. And so for which integrals it is useful. So if we have, for example, a linear combination of sines and cosines in the denominator. So let's do the substitution. Okay, so t equals tangents of x over 2. So x equals 2 arctangents over t. Then dx equals 2 dt over 1 plus t square. And cosine of x equals 1 minus t square divided by 1 plus t square. And now let's now write down the integral that we received. So dx, so instead of dx we have this expression, and here 5 minus 3, so this integrals this fraction, so minus 3. Okay, so let's do like this for now, and then we will write so then we will reduce simplify this fraction, this integral. So what do we have here? So 3 here. So 5 1 plus t square minus 3 1 minus t square. So 1 plus t square is eliminated here. So let's do it from the next line. And now expand in brackets. And we actually will receive the table integral. So 5 minus 3, so 2. And 5 minus 3, yeah, so 2. And 5 plus 3. Oh, so 8 plus 8t. Damn it. Plus 8t square. And also we can reduce 2. Why not? Now using our favorite differential entry technique. So because yeah, so what we'll have, so d of 2t here, and we will have the following. So 1/2 arctangents over 2t plus c. Yeah, and don't forget about this. So where t equals this expression. So any questions about this exercise? Okay, as I see no questions. So now let's look into exercise J, and we won't solve it now. We will just look how to solve it. So we use here another substitution, t equals tangents of x. Then the sine of x is transformed in the following way. And so integral is rationalized, and after some transforms, we have the following. We receive the following integral. So we receive finally we have the arctangents. So table integral. So any questions about J maybe? It looks even easier than I. Okay, now if you have no questions, let's move to trigonometric substitutions. So when do we use trigonometric substitutions? We use it when we have to integrate irrational functions when they look like this. So like this is a rational expression. So this is the expression that depends on x and the following irrationalities. So if we have a square minus x square under the root, we use substitution x equals 1 or equals a sine of t. When we have expression square root of a square plus x square, we use the substitution x equals tangents t. And when we have irrationality x square minus x minus a square, we use the substitution x equals a divided by cosine of t. So now let's use these substitutions in the following exercises. So exercise A. So we have the following integral. So square root of 9 minus x square divided by x dx. So now let's use the trigonometric substitution. So x for such substitution we use substitution. So a sine of t. So 3 sine t. Then dx equals 3 cosine of t dt. And now let's see what we receive here. So 9 minus 9 sine square of t by 3 sine of t, and multiplied by cosine of t, so dt, by 3 cosine of t. So let's now expand this square root, and let's see what do we have. So it will be 3 cosine over t. So actually, yeah, let's move 3 out of brackets. And here we have cosine square of t. So we have such expression. And how to solve it? Easily. So we do the following stuff. So we just expand this expression cosine of square of t. So it equals 1 minus sine square of t, and we divide by sine of t. So now expanding everything. So 1 over sine of t, or also it is seconds of t, so it is the table integral, and minus sine of t. So now let's integrate. Okay, let me look the integral of seconds. It is not such a common. Oh no, coseconds, because we divide by sine. So the integral is the following. So logarithm of tangents t over 2. So done with this integral, minus 3 cosines over t plus c. And also don't lose the initial variable where t equals arc sine over x over 3. Any questions about this exercise? Okay, as I see, no questions. So let's move next. So we have the following integral. Uh, 2 plus x, so square root of 2 plus x square. So now we use the following trigonometric substitution. So x equals square root of 2 tangents t. Then t equals 1 over square root of 2 arctangents of x. And tx equals square root of 2 cosine square over x. Oh, square cosine square over t dt. So now let's rewrite the integral with new variables. So 2 plus square root of so square root of 2 plus, yeah, so 2 plus 2 tangents square of t and multiplied by this expression. So how can we rewrite this expression? So let's remember one of main trigonometric equalities. So the following: 1 plus tangents t equals 1 over cosine square of t. So the following expression we will have. And now, so let's calculate. So we basically have square root of 2 divided by cosine of t and multiplied by this expression. So finally we have the following integral. So two integrals of 1 over cosine square from t. So how to calculate it? We can again make one more substitution, but what we don't do it. We will do the following. So we will perform the following action. So we will take this integral by parts. Yeah, let me write that it is I. Yeah, I. So from x, for example, and I from t is the following. So we will take it, we will calculate it by parts. Yeah, let's also, let's better rewrite it. So what we will have. So cosine of t, and here is cosine square of t. So u equals, so we will take 1 over cosine of t, and du equals, so let's differentiate it. So dt, of course. So sine of x actually by tangents, or sine of t by tangents of t. So that's what we have. And for dv, so dv equals this expression. And v equals tangents of t. So what we have? So cosine, so tangents of t divided by cosine of t minus this expression. So tangents square of t multiplied by sine t dt. Let me check if everything is correct here in my recordings. Stop. Yeah, my bad. So tangents t divided by cosine of t. So that's really my bad. So I see that something is wrong. So tangent square of t by cosine of t. And if we write it in details, so now let we transform this expression. So tangents of t by cosine of x minus so what we will have the following expression. So 1 Okay, let's write the integral. So sine square of x of t, not cube, but square. Sine cube of t divided by cosine, so sine square of t by cosine cube of t dt. And if we expand it, yeah, I don't know why I wrote brackets, but okay. No, not here. So we have, so 1 minus cosine of a square of t. No, no, t is not in the exponent. Sometimes I hate my math type, but a little bit. So if we expand here, what we will receive? So 1 over cosine cube of t minus 1 over cosine of t. So we received once more the integral that we had at the beginning. So if we can rewrite it. So I from t, so the second integral I from t equals so tangents of t over cosine of t minus so this integral, so it will be plus this integral that will be in where cosine is power of 1 and minus I from t. So we returned to this integral, and let's solve. So let's solve this equation. So 2I from t equals so this, and we have the table integral for seconds. So for 1 divided by cosine of t, and it is the following: logarithm of tangents of so t over 2, t divided by 2, and plus p divided by 4. So this table integral plus c. And it is actually equal to this initial integral. And also let's write down what does t equal. So any questions about this exercise?
I may have a question.
Mhm.
S- so, is the second I of t you put here as in the tangents of t by cosine of t and the dt cosine of t minus I of t a different I of t than the first one, or are they the same?
Stop. Which line? So which expression, first of all, is interesting for you? This, the last one, or
Yeah. Is the last one is the last expression the same as the tangents of t by cosine of t minus uh, a differential of 1 by a cosine a cube of t uh, uh,
oh,
minus 1 by cosine of t dt.
okay.
Are
Let
they
me
same? or are they different things?
Oh, maybe for better understanding, let me expand this expression. So, if I expand it, no, stop. So, if I expand it, what I receive? So, the following integral. So, this integral. So, plus this integral. So then we receive, so this integral equals this expression. So we received it by integrating by parts, with integration by parts. So we return to the initial integral, so we just we can find it from the equation. So have I answered your question or not clear enough?
Hmm.
So yeah, feel free to ask if you need more explanation. Vitaly, your question, right?
Yes, yes. So then what about the last expression of the I of t? Is it how come there's another one there's another I of t in it?
So you do you mean this one, right?
Yeah, is it a different I of t? Like
No. Okay. So this is actually, yeah, I can write it like this, just I1, so such index, not to confuse you. Yeah, and actually I1, so it is, so this recording, so just for even for, no well for your for more understandable. Okay, so one recording for one same values. So these values are the same. So this integral, so we received, and we have this integral here, and I just replaced it with I1, and that's it.
I see. Oh, all right.
So
Thank you.
have I answered? Yeah.
I suppose so, yes.
Okay, and I just solved the equation with respect of I1. Bogdan?
Yeah, I also have a question. When we made the substitution
Mm-hmm.
with t, shouldn't be this square root, 1 over square root of 2, be the argument of arctangent, like inside of arctangent.
Oh, yeah. Yeah, thanks for your attention. Uh, of course, yeah. That was a good question, yeah. So we divide x by square root of 2. And let's also correct it here. So more questions, comments? Okay, as I see no questions. So now let's solve the last exercise. And we will go for a break. So we have the following integral. Another kind of irrationality. So dx divided by x cubed and multiplied by square root of x square minus 1. So we do the following substitution. This module. So x equals 1 over cosine of t. So dx equals tangents of t. over cosine of or cosine square of t. Oh no, just tangents of t divided by cosine of t. dt, and let me make small spaces. And t equals arc cosine of 1 over x. Okay, now let's write a rationalized integral. So dx done. Then 1 over cosine cube t multiplied by, so no, by tangents of t dt. So just remembering you this expression. So 1 minus no, so 1 over cosine square of t minus 1 equals tangents square over t. So that's why we received it. So what can we simplify? So first of all, let's remove tangents of t. So cancelled it. And now we also can cancel this. So cosine of t. So 1 power of cosine of t. So basically we will have the following expression: cosine square of t dt. We already know how to solve this, how to calculate such integrals. So we just reduce the power of this expression. So 1 second by 1 plus cosine over 2t dt. So the following answer will be t plus 1 over 2 sine over 2t and plus c. And what about odd variables? So this integral was quite easy, so fast to solve. Any questions about this exercise? About the whole lesson, previous lessons, other questions? Okay. If no questions, let's finish our lesson. Thank you for your attention. Have a nice day. Stay safe. Goodbye, and feel free if you have some questions.
Thank you. Goodbye. Have a nice day.
Thank you a lot.
Goodbye.
Goodbye.